As a collective whole, humanity has always pursued the unknown. At first, this was the exploration of our planet, but as time moved on, we started to wonder more about the heavens above us and their nature. Over time, we have developed more complex tools and instruments, allowing us to answer these questions. Some of the first tools we used were telescopes, but this small peek into our universe has only left us with more questions. So then, we decided to go there ourselves using special spacecraft propelled by rockets. But this begs the question, what exactly are rockets? Well, rockets rely on Newton's third law of motion. For every action, there is an equal and opposite reaction. They achieve this by propelling matter at high velocities backwards, thus creating forward thrust. With that covered, we can now move on to the different types of rockets. Solid-fueled rockets. Solid-fueled rockets typically are made up of a solid fuel and a solid oxidizer mixed together using carbon to stabilize the burn rate. But there are also solid-fueled rockets that are hybrids and use a fuel such as paraffin wax and are liquid oxidized. There are also solid-fueled rockets that are air oxidized using a ram scoop. The main limitation with solid-fueled rockets is the ability to control the burn, so it burns fast enough to produce sufficient thrust, but not so fast it explodes. Heat is also a problem with this type of engine. This type of rocket is used as boosters for the space shuttle and other spacecraft. Liquid-fueled rockets. Liquid-fueled rockets normally operate by combining a fuel such as a petroleum derivative, liquid hydrogen, or alcohol with a liquid oxidizer, such as liquid oxygen or liquid nitrous oxide, inside of a firing chamber where they are combusted. The heated gases are then expelled through a nozzle to produce thrust. The main limiting factor with this type of engine is the ability of the rocket nozzle and firing chamber to withstand the heat of the combustion process. This type of thruster is typically used for manned spaceflight, satellites, probes, and space freight. There are three main types of electric space propulsion: electrostatic, electromagnetic, and electrothermal. Electrostatic ion thrusters. Electrostatic ion thrusters work upon the principle of accelerating positively charged ions at near relativistic speeds using alternating electric fields or a negatively charged grid in order to produce thrust. To make the required ions, an inert gas like xenon is bombarded with electrons by a cathode or by running a strong electrostatic field through a liquid metal like cesium. This type of thruster is commonly used on space probes and satellites. The systems included in this category are the gridded electrostatic ion thruster, the Hall effect thruster, and the field emission electric propulsion thruster. Electromagnetic thrusters. Electromagnetic thrusters generally operate by using an inert gas like argon or xenon and ionizing it into a highly energetic plasma, which is then accelerated using electromagnetic fields and focused using a magnetic nozzle. Although not in implementation yet, they will be used for deep space probes, manned space travel, and for reboosting the International Space Station. The systems included in this category are pulse inductive thrusters, magnetoplasmodynamic thrusters, the lithium Lorentz force accelerator, electrodeless plasma thruster, and the helicon double layer thruster. Electrothermal thrusters. Electrothermal thrusters operate by heating up the propellant electronically using microwaves, an electromagnetic field, or resistive material with a current running through it. Heating up a propellant, such as xenon, will cause it to expand, and the resulting gases can then be channeled out of a nozzle just like a standard chemical rocket, or further energized into a plasma for more thrust. These thrusters are used in some satellites and space probes. The systems included in this category are the resistojet, arcjet, microwave electrothermal thrusters, and the ion cyclotron heating thruster.